So there are also situations where we want to prevent bugs before they happen. One method for doing this is called assert statements. So you can think of assert statements as essentially internal checks within your program. These are statements that you define when you're first writing your program and hopefully trying to prevent bugs from happening later on. And assert statements define conditions that must be true. The syntax for an assert statement is assert some condition that you know has to be true at a given point in time in your code in order for the function to be behaving properly, comma, an error message that you want to be output if that condition is ever false. So the purpose of assert statements is to guarantee that at some given line of your code, some condition is definitely true, and otherwise, a readable error message is output to let you know later on what might be causing a bug as soon as it's introduced. So we're going to get into a quick example of how you can use assert statements yourself. So we'll go back to our trusted example, isPal. Here, one example of an assert statement might be, I want to assert the input to isPal. And actually, before I do this, let me show you why. So let's say I want to call my isPal function on a number, right? 121 is a number that's a palindrome both forwards and backwards. But if I try to call isPal, I get this hard to read error. Type error, int object is not subscriptable. And I get this kind of confusing traceback that's not immediately clear to me. And if I try isPal, let's put in another unexpected input, say a boolean. Again, I get bool object is not subscriptable. So we can see here that, as we stated earlier, isPal is a function that's defined to expect a list. And so it might be useful to assert that the type of the input, so in this case, type of x, type is a built-in function that'll provide to you the type of a given variable is equal to list, right? So I know this condition has to be true at this point in the function, or we have a problem, and I want to catch it immediately. So if type is equal to list, then I want to output the error in the case where it's not true. isPal expects a list object. Cool. So this is my assert statement, and this is what will be output in the case that the assert statement is ever false. So if this statement is ever broken, this error message will come out. So let's try this. Now, if I call isPal on a number, I'll get an assertion error, isPal expects a list object. Great. This is much more readable, and the error is happening inside of the isPal function, which was the origin where the error was first introduced, instead of inside a reverse list. This is great. And we see the same error appears if I try to call isPal on any other broken value that it's not expecting. Awesome. Now, I'd like you all to do the exercise of coming up with the assert statement for isPal n. In this case, I want you to do more than just checking the types of its inputs. Yes, n has to be an integer, and list has to be a list object, but what's another assert statement that you should check for isPal n? Remember, isPal n takes in n, an integer, list, a list object, and then checks whether the first n elements of that list are a palindrome. So I'll give you 5 seconds or pause right here to try that out, coming up with an assert statement that's appropriate for isPal n. All right, so one potential assert statement could be assert that n is less than or equal to the length of the list. Oops. And so the reason for this is because if n is greater than the length of the list, then we might run into an error here, right? Let's say n was 100 and I had a list of length 3, then I can't index into the 100th, or say, since we iterate through the entire range of 100, into the 99th index of a list that only has 3 elements. So this would result in an error, an index error, because I'm trying to access an element of a list that doesn't exist. So instead, let's catch that error immediately and assert that n, the number of elements I'm pulling from the start of the list, has to be less than or equal to the length of the list. And if this is ever broken, let's assert is pal n expects an integer that, or let's say the integer argument, the first argument to is pal n must be an integer that is less than or equal to the length of the second argument, which is a list. This is pretty wordy for an assert statement, but at least it clearly describes what the error might be. So if I try running my function now on some invalid inputs, oh, gotcha. So this isn't important. There's just an issue with this text editor. Sorry about that. So if I try running my code on some invalid inputs, say is pal n called on 6 with a list that only has 2 elements, I'll immediately get my assertion error. The first argument is pal n must be an integer that is less than or equal to the length of the second argument, which is a list. Awesome. Actually, you probably don't want to make your assert statements this wordy, but I just wanted to be explicit as possible about what the error is here. But the great thing is the error was caught immediately instead of running into an index error, which you can imagine with a much larger function might be hard to find and hard to trace where the error was actually introduced. Awesome.